We have a potentiometer circuit here in this, right here. In this potentiometer circuit, we are having a cell in the primary circuit that is 2.5 volts. It is connected in series with a resistor of 2 ohms and this slide wire AB. Now, according to the question, they're telling us that this wire AB is 1.2 meters long and its resistance is 4 ohms, wire AB. And of course, this 4 ohm resistor is in series with this 2 ohm resistor, which is also in turn in series with this cell, the 2.5 volt cell. That is what is making the primary circuit. And in the secondary circuit, we are having a cell Y, which has an unknown EMF and an unknown internal resistance that we have represented by small letter r. Of course, it has also another resistor of 8 ohms, and definitely this is it's connected to this part with a switch K, which switch can be closed and opened. Now, according to the parameters in this question, we are being told that when switch K is open, AJ, which so happens to be the balance length, is 90 centimeters. So in other words, when you slide this contact along wire AB, galvanometer will show no deflection when AJ is 90 centimeters. That is on condition that K is open. Now, when K is closed, when you eventually close K, and therefore you're bringing this 8 ohms into the secondary circuit so that it's no longer redundant, if you slide this jockey along the slide wire AB, it's the point where the galvanometer will show no deflection, which will be the balance length AJ, will be 87.7 centimeters. And now with this kind of question, there are things we are being told to find the EMF of this cell Y. So this is how. For us to find the EMF of this cell Y, we need first of all to find the PD per unit length of this primary of this slide wire. After finding the PD per unit length of that slide wire, we know that when K is open, this 8 ohm resistor is redundant, and so it means that the potential difference across this cell, which so happens to be the EMF of that cell, will be equal to the potential difference across the balance length AJ. That is when K is open. So we need to first find. So it means that when we get the PD across AJ, which we get by saying it is PD per unit length, which we denote as K, times the balance length L, which in this case will be 90, we will be able to get the value of E, which is the EMF across that cell Y. So we begin with our calculation. Now, of course, to find the EMF of cell Y, we have to first find the amount of current, the primary current that is flowing through this primary circuit, which we are denoting by IP. So for us to get the primary current that is flowing through the value of IP, it's going to, from Ohm's law, V is equal to IR. So when we make I the subject of the formula, IP is going to be V over R. RV in the primary circuit right here is 2.5 volts. So it's going to be called 2.5 volts, divide that by the resistance. By resistance here, we're talking about the effective resistance in the primary circuit. Now in the primary circuit, we're having a slide wire AB, whose resistance is 4 ohms. Its resistance is 4 ohms according to the question. So we have 4 ohms that is in series with 2 ohms. So it means that it is V over R, which so happens to be 4 plus 2, and definitely 2.5 divided by 6, we get 5 over 12 amperes. So this is the amount of current that is flowing in the primary circuit, or the one that is being produced by that cell, the primary cell, and it is flowing through that slide wire AB. So now that we know that the current flowing is that, then we go ahead and find the PD per unit length of that slide wire AB. So to find the PD per unit length, we know the PD across AB. We first find the PD across AB. After getting the PD across AB, then we divide that PD across AB by the length of the wire so that we're able to get the PD per centimeter. So this is what we are doing here. We know that from Ohm's law, V is equal to IR. But in this case, since we want to find the potential difference across AB, potential difference across AB is going to be the current that is flowing through that wire, which is IP, the primary current, which we got here previously. Multiply that by the resistance of the wire AB. And the resistance of the wire AB, according to our question, is 4 ohms. So it means it's going to be the current times the 4 ohms, which is the current, which is 5 over 12 times the 4 ohms. When we multiply that, we're able to get 20 over 12 volts. So 20 over 12 volts so happens to be the potential difference across the entire wire. But remember, we're interested in the PD per unit length. So we shall go ahead and get that PD of the whole wire AB, which so happens to be 20/12. We divide that by the length of the entire wire. According to our question, the length of the wire AB is 1.2 meters. So it means it's going to be 20/12. Divide that by 120 centimeters. So since we want the PD per centimeter, it is 1.2 meters, that's 120 centimeters. So it is the potential difference across AB. Divide that by 120 centimeters, and we're able to get the PD per unit length, or the PD per centimeter, which is 1/72 volts per centimeter. Now the alternative way of getting PD per centimeter is also, we can get it by, we know PD per centimeter, which is V, is going to be equal to I times R, I being the current that is flowing through that. So we get PD per centimeter is equal to the current flowing through times the resistance per centimeter. We know that the current, primary current going through the slide wire, is 5/12, which we got right here. Multiply that by the resistance per centimeter. Now, according to our question, we know that the resistance of this wire AB is 4 ohms. So we get the resistance of the whole wire, which is 4. Divide that by the length of the wire, which is 120 centimeters. It is what we've done here. So the resistance is 4. Divide that by 120 centimeters. So this is the resistance per centimeter. And when we multiply this by that, we're able to get our answer straight, which is 1/72 volts per centimeter. So now we have the PD per centimeter of this wire. Now that we have the PD per centimeter, now we can go ahead and find the potential difference across that balance length. Remember, we were told that when K is open, the balance length we get is 90 centimeters. And when K is open, it means that this 8 ohm resistor is redundant. So it means that the PD across AJ is going to be equal to the EMF of this cell. So meaning that we go ahead and get the EMF E. So therefore the EMF of cell Y is VAJ, which is 90. So we know that the potential difference across this balance length is going to be equal to the PD per unit length, multiply that by the balance length. The PD per unit length, we got it as 1/72, multiply volts per centimeter, multiply that by the balance length, which is 90, which is here in the question, and we're able to get the EMF of cell Y, which we are looking for. And definitely our answer here is 1.25 volts. So that is first part of that question. So the second part of the question, we're required to find the internal resistance R of this cell. The internal resistance has been represented by that R. When K is closed means that this 8 ohm resistor has been brought into the circuit, into the secondary circuit. And when the balance length is obtained, it means that no current is going through the galvanometer, since it's at zero deflection, meaning that all the current being produced here is going through that 8 ohm resistor. So now it means that for us to be able to get the balance length, the value of R, we should take note that the potential difference across this balance length at balance is equal to the potential difference across that 8 ohm resistor. And that is one thing that we are going to use to help us get that value of R. So first of all, we need to first get, for us to get the potential difference across this, we know that the potential difference across that balance length is equal to the potential difference across the 8 ohm resistor. And we know that the PD across the 8 ohm resistor is given by V is equal to I times R from Ohm's law. And the I is the current that is going through the secondary circuit. So we need to first get that current going through the secondary circuit. And in a way, that is how we will be able to get the internal resistance R. So first of all, we need to first get the current that is flowing in the secondary circuit. So from our right up here, we know that the internal resistance of cell Y, that is required, we know that when K is closed, that balance length is 87.3 centimeters. So for us to be able to get the current flowing in the secondary circuit, since at balance no current is being drawn from the secondary circuit to the primary circuit, it means we are going to treat this like as though we ignore this, like this thing does not exist. So we are looking at this downer circuit the way it is. All current is being produced from here and it's going through the 8 ohm resistor like that. But we know that the potential difference across this at balance, this resistor, is equal to the potential difference across that portion of the wire at balance. So what does that mean? It simply means we use this expression E is equal to IS into R plus R, since we are looking for internal resistance R. Now this is likened to being like saying V is equal to I times R. It's the same thing, only that because here we are having a cell whose internal resistance is not negligible, we know that our potential difference V so happens to be our EMF. The EMF of this cell Y is giving us the current going through the secondary circuit, which is I, times the effective resistance in that circuit. And of course the effective resistance here is a combination of the external effective resistance, which happens to be 8, plus that internal resistance. Remember that when we are dealing with internal resistances of cells, when we are calculating, we deal with the internal resistance as though it is in series with the effective resistance in the circuit. So when we make IS the subject of the formula, this is how it turns out to be. And we know that IS, which so happens to be the current in the secondary circuit, is going to be given by our E, the EMF, which is 1.25. Now 1.25 is the EMF we got of the cell from this in our previous calculation. So it's 1.25, divide that by R, capital R, which is 8 ohms, plus the internal resistance R, which we're looking for. So this is an expression for the current that is being produced and it's going through the 8 ohm resistor. So we go ahead and find, we know that the PD across the balance length when K is closed, which is 87.7, the potential difference across that portion of the wire is equal to the potential difference across that cell, which we have written here, that the PD across the balance length is equal to the PD across the 8 ohm resistor. So the PD across the balance length is given by the PD per unit length of that wire times the balance length, being equal to the PD across the cell is going to be the current that is going through that, I mean not the cell but the resistor, the 8 ohm resistor. So it's going to be the current going through the resistor, multiply that by the 8 ohm resistor. This is coming from Ohm's law. Of course, from earlier, our value of K, which is the PD per unit length we got from the first, when we're answering the first question, is 1 over 72. Multiply that by the balance length, which so happens to be 87.8 centimeters. This was got from our question, is equal to the expression for the IS, the current that is going through the 8 ohm resistor, which so happens to be this. It is what we have replaced here. Multiply that by the resistance, which is 8 ohms. And from this expression, we make R the subject of the formula because we are interested in finding the R, the internal resistance, and our final answer is 0.2 ohms. So from what we've been able to do, you can go ahead and try out this number. We have a slide wire AB right here. It has, this potentiometer circuit has a cell X whose EMF is 4 volts and has an negligible internal resistance. When K is open, the balance length is 56.25 centimeters, and when K is closed, the balance length is 51.5 centimeters. Now this balance length is this slide wire AB is 1 meter long and its total resistance is 4 ohms. So you can go ahead and find the EMF of Y. I expect you to get 1.5 volts and the internal resistance of Y is 0.992 ohms. In case you need me to help you out on this one, just let me know in the comments below.